Good morning and welcome everyone again. I think we can now start the meeting. The attendees list is a little bit stable now. So thanks again for joining us today for this Blue Cloud webinar on the marine environmental indicators, one of the different Blue Cloud demonstrators that will provide you with more information about the aim, but also the activities that has been done until today within the project. Just for starting, I would like first to remind everyone that you can find on our website, bluecloud.org, all the different webinars that has been held on other demonstrators in the past months. And you can find there also very relevant information about the results, the preliminary results of the different demonstrators, like, for example, on aquaculture and fisheries, very relevant as well. And you can today attend this event. We will present you this set of slides, but then you will have the possibility to ask questions through the chat and to the Q&A function. And even if you want to speak, you will be allowed to raise your hand and then talk directly with our speakers. If you can go next slide, please. So the agenda for today and our speakers. I will give a very brief introduction about the project, our vision, mission, and which are the different demonstrators. I'm Francesca Spagnoli. I'm the coordinator of the Blue Cloud project, and I'm working for Trust IT Services, which is a small company based in Pisa, in Italy. Then we will directly dive into the demonstrator's prototype and initial marine indicators, thanks with the presentation from Massimiliano Drudi and from CMCC. We will focus on the ocean patterns indicators, and Andrea Garcia Juan will give us an introduction. She's working for IFREMER. We will dive through the storm severity index with a presentation from Willem Noteboom from KNMI. And finally, some benefits and needs of marine carbon indicator with a presentation from Benjamin Pfeil from the University of Bergen. And we'll give some bit more time for question and answer at the end, as explained. Next slide, please. Just a little bit of information of Blue Cloud. Blue Cloud is a project funded under the Horizon 2020, the Future of Seas and Oceans flagship initiative in 2019. The project lasts for 3 years and it started in October 2029. So it's already more than a year that has gone. The budget is around roughly 6 million euros, so quite a huge project. And the partnership includes more than 20 partners and also 13 Blue federated infrastructures are involved in the process, and we are, of course, starting from the activities and results that have been already done in this set of infrastructures, and also taking advantage of already pre-existing facilities and tools and services. Next slide, please. The vision of Blue Cloud is to create an environment for the Blue community, which means offering both a huge set of multidisciplinary data resources, but also a set of added value services and tools for the benefit of the future marine research and the Blue economy landscape. Next, please. Our mission is, of course, to piloting this cyber platform, bringing together and providing access to this multidisciplinary data from observation, but also in situ and remote sensing, a set of analytical tools and computing facilities, which combined, of course, can be of great knowledge and also of support for the world marine community. Next, please. We are aiming then to create this smart federation of existing data, computing, storage, resources, and analytical services by also exploiting the Blue Cloud virtual research environment, where any kind of researchers or let's say experts interested in exploiting this field can access computing and analytical services on top of the platform, and also data discovery and access service to facilitate the sharing of data between different users from multidisciplinary data sets. Next slide, please. Next, please. We have 5 real-life demonstrators, 2 focused really on biodiversity, 1 on zoo and phytoplankton, and another one on EOV products. Another one is also focused on plankton genomics. Today we will present the one on marine environmental indicators, and as I said, we have also one on fisheries and another one on aquaculture. these are all very relevant, and you can find here the link to get more information about the demonstrators as well, and contacts of people responsible for each of them. Next, please. So we will start now with the presentation from Massimiliano Drudi on demonstrators prototype and initial marine indicators. Thanks.
Thank you. I am Massimiliano Drudi, and I'm giving you this presentation on demonstrator prototype and initial marine indicators. Next slide, please. The specific objective for this demonstrator are to calculate and distribute online information and indicators on the environmental quality of the marine area. Then obtain new added value data applying big data analysis and machine learning methods on the available input multi-source datasets. And finally, to enable user to perform online on-the-fly operations, such as selecting portion of dataset to perform statistical analysis or display the data. Next, please. So the target audience is people dealing with monitoring activity for the Marine Strategy Framework Directive, and also people dealing with Sustainable Development Goal number 14, life below water. And now in version 1, that is our beta version, we are starting to provide support for those two policies. Then next year in version 2, there will be an improvement of the support that we can provide. Next, please. What are we doing? We are developing a virtual laboratory, and the design is based on needs and requirements provided by environmental agency, basically. And we are bringing together into a unique service within this virtual laboratory, innovation, data, resources, and expertise. And it is available a prototype user interface which allows the user to perform some operations such as to select a portion of input data for a specific area and time of interest, generate new added value data, or display the data by means of tables or graphical visualizations. Next, please. In this prototype, we are using a data source from the Copernicus Marine Service, more exactly the Mediterranean Sea Analysis product, which is available from year 1987 to year 2019. And we are using the fields of temperature, salinity, and currents. And in this prototype, it is possible to use the years from 87 to 89. Next, please. The output data we can generate are maps, monthly or annual mean maps, monthly or annual climatology maps, and time series such as monthly or annual mean time series or monthly climatology time series. And the possible output fields are temperature, salinity, water density, kinetic energy, and currents so far. Next, please. The virtual laboratory is already available at this link. Now you can register to get the access to the virtual laboratory. And in this month will be available the beta version of the demonstrator. Next, please. Okay, now I'll tell you something about the interface. I will present two sections of the interface. The first one is the generate new data section, and then there will be the main data section. In the generate new data section, in A, it is possible to select the input data source. And as I said before, right now it is possible to select only one data source, which is the Mediterranean Sea analysis from the Copernicus Marine Catalog. And it is possible to use it from year 87 to 89. Next, please. Then B and C, it is possible to select the output data, providing the output type and the output environmental field. In this example, the selection is a monthly mean time series of temperature. Next, please. Then it is possible to select the time of interest. And in this example, we provide the start time January 87 and the end time December 87. Next, please. There are different time specification because it depends on the output type that it is selected. For instance, for a monthly min map, the interface will ask for a month and for a year, while for instance, for a monthly climatology time series, the interface will ask for a start year and year, and so on. For the other output type, there will be a specific time specification that the user have to provide. Next, please. The geographical domain is the last information that it is possible to select, providing a longitude, latitude box and a depth layer of interest in meters. Then it is possible to submit the job. Next, please. So now we can take a look to the My Data section, in which a user can check the list of all the submitted jobs, and for each job check the information related to the output data and the information related to the job. The information related to the output data are the same that have been used to create the job, and then it will be available so creation time, status, and at the end also the output. And clicking on output, next slide please. Clicking on output, it will be possible to see the plot of the output, that right now it will be a map or a time series, and it will be possible to download the picture or download the data as .cdf file, or download the log information of the execution. Next slide, please. A conclusion for this first presentation. We can say that data from different existing EU data sources are available inside this demonstrator within a unique service, and an online flexible analysis tool is facilitating the user to display and generate the new added value data to assess the environmental quality of marine areas. And the perspective for next year is that new data sources will be made available. There will be additional scientific-based algorithms that now we are developing, and there will be a further development of the interface for the user to make possible interaction in a better way and the visualization of the output data. And this is the last slide.
So good morning, everybody. My name is Andrea Garcia, and I'm going to present to you the Ocean Patterns Indicator. I have been working in this indicator together with Kevin Ballen and Guillaume Mas from IFREMER. Next slide, please. This is my presentation plan. So first of all, I'm going to explain to you what is the Ocean Patterns Indicator and how it works. And then I will introduce the Jupyter notebooks we have developed. Next slide, please. So what is the Ocean Patterns Indicator? This indicator is based on a profile classification model that allows to automatically gather ocean profiles in clusters depending on their vertical structure similarities. So depending on the dataset, these clusters can show spatial or temporal coherences, and that's what we call the Ocean Patterns Indicator. So here you are a sample diagram of how this analysis works. From a dataset of ocean profiles, we apply the PCM that in an unsupervised way make different groups with the profiles. Here, each point represents one profile. And then by plotting these different classes spatially or temporally, we can find some coherencies. For example, here in the figure, we can see that some classes are more common in Black Sea, for example, and other classes are more common in winter or in summer months. That's the kind of coherencies that we are looking for, and that's what we call the Ocean Patterns Indicator. Next slide, please. So how this profile classification model works. This classification model is based on a clustering method that it's called a Gaussian mixture model method that decomposes the probability density function of a dataset into a sum of Gaussians. So in the figure on the left, we have example of this process in one dimension. So we can see that the probability density function is decomposed into 5 Gaussians. So if we want to use two-dimensional ocean profiles, this process get a little bit more complicated, but that's the main idea. So as we are using an unsupervised classification method, the user should only choose the number of classes, and in the input, there is no spatial or temporal information. It means that the spatial or temporal coherencies came out naturally from the data when we plot the results. And an advantage of the Gaussian mixture model method compared to Cummings, for example, is that we are able to compute the probability of a profile to be in a class. And that's a very useful information, as I will explain to you in a few minutes. Next slide, please. So the Ocean Patterns Indicator is computed using the PixPCM Python software. And if you want more information about the method, you can see Mast et al. 2017. And next slide, please. So the computation of the Ocean Patterns Indicator has been developed into 2 Jupyter notebooks, a model development notebook and a prediction notebook. And here you have the workflow between them. So in the model development notebook, we design the model, we optimize it, and we train it with a training data set that it's downloaded from Copernicus Marine Service. As an output, we obtain a trained model that is saved in an HCDF file. And then in the prediction notebook, we use the model we had developed in the first notebook to classify another data set that it's also downloaded for Copernicus Marine Service. And as an output, we have some figures, and we can also save the data set, including the model predictions. So in these 2 notebooks, we propose an example covering the Mediterranean Sea, but the user can change the parameter to choose other regions or other variables. And these notebooks are very easy to use because you should only follow the instructions inside. Next slide, please. Yes. Okay. So we also provide 4 pre-trained models that are ready to use. 2 models trained with reanalysis data, both covering the Mediterranean, and 2 models trained using Argo floats data, one covering the Mediterranean and the other covering the North Atlantic. Next slide, please. So now I'm going to explain to you a little bit more in detail each of the notebooks. In the development notebook, first of all, we choose the model parameters. That's the number of classes and the variable we want to use, for example, the temperature. And we load the training dataset from Copernicus Marine Service. So the user will need a Siemens account. Then we create the model and we plot some metrics that would help us to optimize the model. For example, here we show the big index that will allow us to determine what is the best number of classes to use. Here we should choose the minimum in the graph. Then we can save the model in an XCDF file. Next slide, please. So in the prediction notebook, we load the model and the dataset, and the user can use the pre-trained model we provide or the one he had developed in the first notebook. Then we predict the labels. It means that we sort its profile in the dataset into a specific class. Then we generate the plots and we save the data. Next slide, please. We generate a lot of plots and, for example, the vertical structure that is calculated using all the profiles in a class and making some statistics. Here we calculate some quantiles. For example, the median quantile that it's the red line in the figure. Like that, we obtain a standard profile and a deviation for each of the classes. We can also plot the classes in the space, revealing spatial coherences. Next slide, please. And we can also plot the classes in time, revealing seasonal cycles, for example. We also plot the robustness that indicates the probability of a profile to belong to a class, and that will give us an idea on how is the transition between classes. If the transition is smooth, we will have a lot of profiles with low probability between classes. If the transition is abrupt, we will have not a lot of profiles with low probability. Next slide, please. So finally, I would like to give to you some examples of applications. This analysis had been used to study a region with natural boundaries, as we can see in the three figures on the bottom, in the North Atlantic and in the Southern Ocean. It had been also used by Willem and Mas to determine the evolution of the Gulf Stream boundaries during 4 decades using only in situ data. And it had been also used by De Bruyere et al. For tracking the subtropical water signature in the North Atlantic. Next slide, please. So to summarize, the ocean patterns indicator is an easy way to analyze and explore an ocean region using machine learning. And this analysis can be applied to all types of oceanographic profiles, from 3-dimensional numerical simulation to in situ observation, and we can use it with one or more physical or biogeochemical variables. So feel free to play with the notebooks. And next slide, please. That's the last slide. What are we doing next? Now we are working in the ocean regimes indicator that instead of classifying ocean profiles, will classify ocean time series. And this methodology had been already used with chlorophyll data in the Mediterranean, revealing the seasonal structure of the blooms of phytoplankton. So that's all for me. Thank you very much for your attention.
Okay, thank you. Good morning. My name is Willem Noteboom. I'm working for KNMI, which is the Dutch Meteorological Institute. This demonstrator concerns an atmospheric variable, actually wind, and that's included as part of these marine indicators. I have selected the storm severity indicator because we believe that strong winds or storms will impact the circulation of sea and oceans and can therefore be a useful indicator for the blue cloud community. Next. This storm severity indicator is provided for an area or time period. This can be a small time or area for an individual storm, but you can also calculate it for a very long period across, for example, the entire Mediterranean Sea. The data source we use is Copernicus Era 5 data. It's actually the 10-minute wind data, reanalysis data. And from this data, we have derived or pre-processed the daily and monthly grid data. This has been only done for performance reasons to allow interactively calculations of SSI distributions. That I will tell a little bit later on about that. And at the moment, the pre-processed data is limited to the years 87 till 89 and only for the Mediterranean Sea. The user interface that will be provided can then be used to select either daily or monthly grids as a source data, and of course an area and time period, and as a result, method or process is issued that can then provide the distribution, the map, as well as the total SSI score, and this user interface will also visualize the distribution map. Next, please. Some explications for the SSI indicator. As I said before, it can be used to study an individual storm to see how it has impacted very locally the sea circulation. But you can also use it to have a look at an entire storm season of a sea area. And more for climatology, you can look over a very long period of time how the storms, what the storm severity was, for example, across 30 years. And you can compare that to, let's say, 80 till 2010 and compare then to 99 till 2020 to see if there's, for example, an increase in severity, so climate change occurring. But also this SSI can be used as a feature for all kinds of other modules that study the ocean. Next. To illustrate a little bit of the storm severity maps, here you see I selected two monthly SSI maps from the period 1987 till 1989. And the first one is in January 1987. And you see in this time series, well, it's the area before the coast of France. And in particular, you see that this January is nicely spotted in this time series. You see also that in this area there is often storm because you see various high SSI scores. The picture below is a monthly map of December 1988, and we took the area below Sicily. And you see here that that's often a very quiet area, not so much storms. However, just this December 1988, there has been quite a severe storm in this area. Next, please. If we zoom in into these monthly maps and then we zoom into the daily maps, for this January period, this score is contributed by two individual storms, one on the 11th of January and one on the 14th of January. And above you see also for this area, the daily SSI scores, and they are primarily in the winter season. In the summer season, there's hardly any severe storm, which is, which we already know, I think. And the below two pictures, that is this storm of 1988 below Sicily, and it seems to be 2 days of storm, which, so it's basically one storming system and severe storming system to the south of Sicilia. Next, please. And to illustrate the storm, I also made a movie. I made a small movie of this storm. Here you see the wind, and you see indeed that there has been a sort of typhoon to the south of Sicilia that has been there developed on at the 8th of December, and then getting severe on in the 9th of December, and after that it disappeared basically. So that was an illustration of the storm itself. Please, next. So what will I do what we are doing next in 2021? Okay, this data was now only 2 years. However, the ERA data is from 1997. So we will extend the source data to 40 years, also for this climate, that you can study the climatology of the storm severity. And we will further integrate the methods to calculate the distribution maps and SSI score, as well as perhaps other SSI statistics, and also the view services and the user interface with all its control in this D4 science infrastructure, or the blue cloud infrastructure, as you wish to call them. So that are basically the activities for next year. This ends my short presentation about the demonstration. Thank you.
Hi, good morning, everyone. I am Benjamin Pfeil from the Research Infrastructure ICOS Integrated Carbon Observation System and the Bjerknes Climate Data Center at the University of Bergen, Norway. And I'm talking about the benefits and needs of a marine carbon indicator and why it is indicated in the Blue Cloud project. Next one, please. There's an overarching need for a carbon indicator. This one has financial implications. On the left-hand side, we see the price per ton carbon dioxide in the EU emissions trading system. Next one, please. Could you, yes. Carbon or oceanification has a direct impact on the blue economy, and this has a financial impact as well, of course. Next one, please. We are all aware that the carbon dioxide emissions have an impact on climate change, and we have to be able to monitor more closely what is happening. Next one, please. And there's a societal need, and this one is basically represented through the Sustainable Development Goals by the United Nations, how to basically manage to have a sustainable future on our globe. Next one, please. And all of them are basically interconnected. It means financial implications have an implication on money and so on, and I try to show that one within the given examples. This is an example about the global carbon budget. In the figure, you can actually see the emissions, the sinks and sources basically since the Industrial Revolution until now. And this on the top shows the emissions of anthropogenic carbon dioxide, and that's basically due to the burning of fossil fuel and land use changes. And those emissions are being taken up by the ocean, by the land, and by the atmosphere. Next one, please. This one goes more into details. Where are the sources and the sinks? And I'm going to focus on the sinks of carbon dioxide. Next one, please. As you can see, 44%, around half, is staying in the atmosphere, and about 1/4 is taken up by the ocean sink due to air-sea fluxes. Next one, please. And having those two numbers, the land sink is being recalculated. Next one, please. This has financial implications. If you use the current price set by the European Union Emissions Trading System, the EU ETS, that is per December now around 30 euros per ton of carbon dioxide emissions, this results that the value of the ocean sink is currently at nearly 200 billion euros per year. And as you can see in the right-hand figure, those prices are actually quite flexible and they're currently rising. Next one, please. But if you reduce the emissions of carbon dioxide or improve geoengineering as a result of the Paris Agreement, we need to be able to monitor the impact, and the impact of reductions will have an impact on the EU ETS. Next one, please. But if the carbon dioxide is entering the ocean, it has a negative impact on shellfish. And basically, if carbon dioxide enters the ocean, there's a chemical reaction, and that results in changes in the pH level. And those changes actually have a negative impact for shellfish as a commercial product, but even more as a product, being part of the food chain. And those impacts are twofold. First of all, the change in pH has a negative impact on the shell. And this is actually quite vulnerable for if you have small larvae and small shellfish. But the lack of carbonate ion has a negative impact on building the shell as well. They will still manage to build the shell, but it takes more energy and makes them more vulnerable. It means changes in acidity have a direct impact on shellfish farming industry. There have been several showcases in North and South America, and not just on the shellfish, directly for the shellfish industry, but direct impact on marine food chain and for fisheries as well. And there is a need for European ocean acidification or early warning system for the blue economy, as it's currently being built up by NOAA in the USA. Next one, please. But carbon and carbon dioxide emissions are directly related to several of the Sustainable Development Goals by the United Nations. Number 13, climate actions, and number 14 to be mentioned, but to number 2 as well, to the impact on food chains, that means to fight poverty. One of the targets of the Sustainable Developments directly addresses carbon dioxide or oceanification. Next one, please. And oceanification is highlighted by the G7 as well. Next one, please. So there is a potential for many future possible services. On the left-hand side, you see Flux Engine. That's basically a tool developed by colleagues in the UK, Jamie Chatler et al. And that basically gives you the possibility to calculate more accurate the fluxes, so the RC flux. Next one, please. There could be the development as well going towards an ocean acidification early warning app that could be used for the blue economy. Next one, please. Of course, if we have better quantifications of the ocean sink, we would be able to feed better back to the ETC. Next one, please. And of course, we could be able to give more or better data, deliver data better in a way to the Sustainable Development Goals and contribute to their aims. Next one, please. But their current challenges. The top one shows you basically that a lot of the data, the carbon data, does not follow the data flow of operation oceanography. We are not on the left-hand side. We're not on the left-hand side to be as back data, and we are becoming more operational. And a lot of data is the so-called long tail data that is being handled by the scientific community. Next one, please. So data is accessible, but it's accessible via numerous entities. There is not a one-stop shop on how to get the data. And even worse, there's often the uncertainties are not reported. This one gives you just an indication of the possible data sources, but there are actually quite many more we would have to take into account. Next one, please. So the international marine carbon data flow is mature and just becoming ready for higher level services. And now I'm going to show what we're going to focus upon within Blue Cloud. So the first step is to integrate data via interoperable services to recompute the missing essential ocean variable inorganic carbon subvariables. It is not just pH or carbon dioxide, it's actually 4 variables that are relevant. And we are aiming to provide uncertainties whenever possible. This harmonized data access is the baseline for future applications and services and actually makes the data fit for purpose. A lot of data is not being measured for the purpose of oceanification or the purpose to predict the fluxes. It's measured for different purposes, but being able to really have the uncertainty, provide the uncertainties, it makes the data fit for purpose. Next one, please. So on the left-hand side, you see an example of data we try to integrate. Then when we get extra data, we try to harmonize, we try to recompute, we provide uncertainties. The output would be a harmonized integrated carbon indicator, providing state-of-the-art data access, uncertainties, and recalculation of the subvariables. And this will have an impact for the Sustainable Development Goals, for the global carbon budget, for policymakers and stakeholders. Next one, please. And I would like to thank you. If you would like to receive more detailed information, please post them in the chat or write me an email. Thank you very much.
Thanks a lot to all our speakers for these very interesting insights from the demonstrators of environmental indicators for Blue Clouds. I would like now to open the floor for some questions. Perhaps I will start from people who raised their hands. So Anton, if we can give to Anton Ellenbrook the possibility to talk, to ask a question. Okay, you can now.
Yes, okay. So thanks everybody, really cool presentations. For me, my question would be, and maybe also to explain to other participants, how will this become available in a VLab? And how can people use the VLabs? If I am, for instance, a aquaculture producer in Tunisia, and I would like to have this type of data accessible in a VLab, how would I go about to have this for my community, for instance?
Perhaps Massimiliano would like to answer to this question.
Yes, so we are preparing the now, and in this month there will be available the beta version, and progressively we will take care of improve the available methods and sharing methods for the output data. So the slide that we are sharing now provides the link to reach the VLab of this demonstrator, and this is the starting point to engage with this service.
Okay. I don't know if that's fine, Anton, or you have other questions?
It's a good start, but it's so I think also for other people. So how do I, as a community, that I'm not really working inside the Blue Cloud project, but how can I go about to give you a specification of what I would like to have? So, for instance, I am a aquaculture sector, and I would like to have a environmental overview of my aquaculture area. What would be my first step?
Do you mean to have the specific data that you need for this?
So my first question would be, where can I find, do you have a register of data where I can browse what you could make available for me? And then how can I make this a tool that is useful for me in my area with my research question, or my management question? I also am interested in what is the maximum storm that I have to prepare for in my area. So how do I formulate a request to the Blue Cloud project where they can give me an answer, where I can find my data, how I can access it, and how I can compose my overview of my area for my community?
Well, the catalog is still a part that we will develop in the next year, I hope, and probably this is the catalog of available outputs, and this is a first place in which it should be possible to look for something relevant, and in case if something is missing with the with this VLab should be possible, if it is within the scope, to create new value-added data that are relevant for the activities of other communities.
Yeah, but in any case, everyone would like to start with playing with the marine environmental indicators can access the virtual lab. We added also the link on the chat. So I think that there you can also find more information, also an interview about the demonstrators, and then you can already access the VLab through the button in the page. So you can start from that. And if anybody has more questions, we can contact with Massimiliano as well. Thanks. So there are also two questions in the question and answer. One is from Ivan Conesa Alcolea. He's asking, not yet components on organic and biomineralized carbon. I guess this is a question for perhaps our last speaker.
No, it's not a component yet.
Okay, thanks. There was another question, but I think it has been just answered from Benjamin as well. So it was about measurement of dissolved carbon dioxide. I don't know if the question is satisfying,
that was
Luisa.
To me as well, I tried to answer that one. It would be nice to have the carbon measurements more on a European level, basically make it mandatory for various countries to report. It's actually being done for the ecosystem and for the atmosphere, but it's not currently being done for the marine sector. I think having a more sustained approach on how to perform measurements is needed, and that's actually what the research infrastructure ICOS, Integrated Carbon Observation System, is about. At the same time, the Sustainable Development Goal target 14.3 aims to basically have national reportings that basically give feedback to the countries on what they would have to do more and how to have to measure in order to fulfill the obligations towards the SDGs.
Thanks a lot, Benjamin. I see we have two people who raised their hands. Let's start with Raisa Meyer.
Hi, yeah, thank you. I had one question because so far it seems like you're mostly working with the Copernicus data. And I was wondering where you see the main challenges of when it comes to integrating data from other sources into this as well. I feel like Benjamin touched on this a little bit, but I was wondering about some more perspective on that.
Thanks, Raisa. Who would like to answer to this question?
Well, I can say something for this. It's Massimiliano. In this, for this, the data access is of course a challenge because a lot of improvements have been done for the format and for the protocols. They have been made open and formats have been made more homogeneous and so on. And so now somehow we are going to the direction to try to exploit all those improvements in real applications and improve again everything. Including also the issues concerning the data access, because it is important to have computational resources close to the data storage in order to make possible the development of new applications which are able to compute a big amount of data in a reasonable time. And I hope I'm answering to your questions now.
Yeah, thank you. That was certainly one perspective on that. Thank you.
And Francesca, you're muted.
Oh, sorry. I was trying to say that Luisa Giannudi would like to speak as well. So if we can give them the possibility. Thanks.
Yes, hello, can you hear me?
Yes, we can hear you well.
Goes to Benjamin again for the question I did. I know about ICOS, and I know that we need to, for the countries to have like measurements of carbon dioxide, pH, alkalinity, whatever that would help us. But what I actually meant is, if we don't have something more or less like a law, something that would make an obligation or something for the countries, we will end up having scarce data of parameters, one there, the other somewhere else. So I strongly believe that we should apply pressure and have also the marine indicators for carbon system. And we should do this fast. Because, for example, I was asked to give my measurements for the SDGs 14. Okay, I received the email. I can do that, but the data are scarce. The sampling stations are here and there all over the Eastern Mediterranean, so they don't really tell a story. So unless this becomes obligatory for the countries, whatever tools we have and whatever mechanisms might not be enough. That's what I wanted to say. Thank you.
I totally agree on that level. I think everybody working the field, working with carbon data, totally agrees that we need a more coordinated effort in order to really know what is happening. Thank you.
Yeah, we need the pressure. We need the pressure.
And we need the pressure of...
Yeah, from the EU to the countries and from the countries to us. Thank you.
Of course, thank you.
Thank you, Luisa and Benjamin. We have one additional question from Adriani Sunuddin. Speaking of data as new currency to pursue SDGs or as a part of to adapt climate change, many areas are lacking of continuous ocean data based on measurement. Is this particular issues related with the fact of low sink capacity by the ocean?
First of all, I would not say that the sink of the ocean is low. It's actually quite large if you take it over time. So it's a very large sink. I think one of the reasons is that a lot of research has been done by the scientific sector, and even that data has been, and there's an issue as well that those measurements are not funded through, like compared to weather measurements, that they are funded through continuous money flow. Those are basically funded through individual research projects. I think we would have to lift this one up to the next higher level to have more coordinated effort, and ensuring that those measurements are being made continuously and that we use different funding sources. And I think that would be basically satisfying those needs.
Thanks, Benjamin. I think we have another question for you, actually. From Raissa Mayer again. So as DOVs were mentioned in the introduction and in the talk from Benjamin, I was wondering if you're formally working with the panels on the EOV reporting.
Okay, that was, I guess, to me. Was it to me or to who was the question? I wasn't quite sure.
I think it's to you and perhaps also a bit to Massimiliano.
Okay, first of all, if you talk about the carbon, about the panels for EOV reporting, under GOOS, so the Global Ocean Observing System, there is the International Ocean Carbon Coordinating Project, IOCCP, that basically fulfills the need of the biogeochemical panel of GOOS. Where I'm involved in, and we are also involved in the Global Oceanification Observing Network, and basically all the higher level entities working with carbon data on, or with the related EUV inorganic carbon. So what we try to do is an approach that's basically on satisfying the needs of the global community working with this EUV.
Okay, thanks. Any other additional question? If not, thanks a lot for having joined us today. The presentation and also the recording of the webinar today will be available through our website, bluecloud.org, under the demonstrators page. We will add them for sure. You will find it in the next days. Again, thanks for your time in a Friday morning on December. We will hope to see you all back again in the next webinars that will be available, and we will start again beginning of next year in February with the last few webinars on our demonstrators, and then we will invite you to other potential opportunities to collaborate and link up with our experts in the field. Thanks again for joining, and you can find in the chat the link where to access the slides and the recording. Bye-bye.
Bye-bye. Thank you.
Bye-bye.
Thank you.
Thank you.
Bye, thank you.